In this video, we're going to look at a couple examples of how to solve a system of equations using the elimination method. So, the key to setting this type of problem up is that you want both equations to be in the same order. Easiest way to do that for me is to put them in standard or general form, where you've got the x and y terms on the left. Notice how they're stacked on top of each other, and then you have the constant over on the right side of the equation. So before you can eliminate, what we're trying to do is add the two equations together to form one equation. You could subtract them, but I think it's just easier to add. You're not dealing with additional negatives. And in order to add them together, we need the x terms or the y terms to be opposite so they cancel each other out. Notice how my y terms, I have a positive 4y and a negative 4y. If I add those together, I get 0y. So all that's going to be left is the x term. So this is already set up for us to add them together. So 3x plus 1x is 4x. This is 0y equal to 4. So it's really just 4x equals 4. Now I can solve for x, my only variable. So I divide by 4. And I get 1. Now, we're trying to find the solution, so that intersection point between the two equations, so I also need my y value. I need to plug in 1 for x in either equation. Doesn't really matter because the point is supposed to be in both equations. So I'm just going to go ahead and do my first equation. And I want to plug this 1 in for x here. So now I can just solve for y. This is going to be 3 plus 4y equals 23. In order to get y by itself, I am first going to subtract 3, move that over to the other side, and now I divide by 4. And that gives me y equals 5. So my solution should be 1 comma 5. Now I know for sure that works in that first equation if I did all my math right. But in order to double check my work, it helps for us to plug this into our second equation. So the x minus 4y equal to negative 19. We plug 1 in for x, 5 in for y. This gives us 1 minus 20, which indeed gives us negative 19 equal to negative 19. So there's our answer there. One other example that we're going to look at does not have our equations set up so that we can go ahead and add them together. So, if that's the case, you might need to multiply one or both equations in order to get those terms that are going to cancel each other out. Well, let's say this first equation had a 4x. If we just multiply the negative 2x by 2, we get a negative 4x, which when you add to the top equation, a positive 4x, the x's are going to cancel out. And so we would just need to multiply the entire bottom equation by 2. Okay? And now it's essential that you multiply every term in the equation by that same number. Okay? Otherwise, if you just change the one term, you're completely changing what that line is. Right? Well, unfortunately, we don't have 4 as our coefficient for x in the top equation. So we can't multiply negative 2 by a whole number to get negative 5. And we can't do something simple with our y terms either. So provided that these are smaller numbers, I typically will just multiply one equation by the other coefficient. So what I mean by that is if I want to eliminate my x's, Well, 5 times 2 is 10. So I could multiply my top equation by 2 and my bottom equation by 5, and I'm going to end up with a 10x on top and a negative 10x on the bottom. I could do the same with my y terms, where I'm multiplying the top by 4 to get a negative 12, multiply the bottom by 3 to get a positive 12. Okay, so it doesn't really matter which way you do it. I'm just going to do the x's. So, go back here, erase those. Fortunately, I already have one positive and one negative x term, and so I don't have to deal with multiplying by a number. So I want to multiply the entire top equation by 2, the entire bottom equation by 5. All right, so I have to distribute 2 throughout this whole equation here, and 5 throughout this whole equation here. I don't want to get any of my equations mixed up, because we're going to have to add. I want the 2 equations I need to be stacked on top of each other. So I'm just going to completely rewrite these over to the right. When I distribute my 2, I get 10x minus 6y equals negative 14. When I distribute 5 in the bottom equation, I get negative 10x plus 20y is equal to 70. 70. Okay, so now looking at my 2 new equations, which are really the same equations that I just had, but by multiplying the entire thing by a different number, I'm just making it look a little different so I can do my elimination here by adding them together. So my x's cancel out, my y terms become 14y, and here I get 56. Now I can solve for y, divide by 14, and I get y equals 4. Now I just need to plug 4 in for y into one of my equations and solve for x. Now I could use either of my initial equations. I could use either one of the new equations that I just used. But I'm just going to take one of the original ones, maybe just the top one. And I'm going to substitute 4 in for y right here. So now I get 5x minus 12 equals negative 7. Add 12 to both sides. Cancel that 12 here, and I'm left with 5x on the left, 5 on the right. Divide by 5 on both sides. Gives me x equals 1. So my solution looks like it is 1 comma 4. If I want to double check that, I just plug 1 comma 4 into my second equation and make sure that that holds true